Great. O'Dwayne, are you ready?
Yeah, I'm ready.
All right, take it away.
My name is Sarah Allen.
Ah.
My day job.
Hi, Tara.
You funny.
I'm just saying. All right. So my name is O'Dwayne Irving. I'm a software developer at ThoughtWorks. And what I'll be doing today is just a basic Arduino tutorials, just basic setting up of Arduino, how to code in Arduino. So we're going to do 3 projects if time permits. We're going to get an LED light blinking. We're going to get 2 LED lights blinking simultaneously, and then we're going to work with a sonar sensor, which is very cool. These are used on autonomous robots to I guess, sense distance around them. And just for like a quick look at my little setup in a way, it looks like this. So this is Arduino. It's the Uno. It's the smallest one. No, it's one of the smallest ones they have. They have smaller than this, but for our purposes, we need a couple more pins than the smaller one has. So this is the Uno. As you can see, the LED. We have a red LED here. We have a green LED here, and this bad boy in the front right here with these 2 cylindrical-looking eyes is a sonar sensor. What a sonar sensor does is sends out pings, and you can't hear it. It's not sensed at the human at the sound of that the human ear can hear, but it sends out sound and it receives the echo back. So it's like if you shoot sound at the wall, it bounces back at you. This is exactly what this does, and it calculates distance based off of the speed of sound. I'm here with.
Hi, my name is Julia. I'm also a developer at ThoughtWorks. And yeah, I'm just sitting beside O'Dwayne and just watching the show.
Thank you. All right, so let's get started. For those who don't know about Arduino, it's open source It's an open source hardware platform, and you can go online and you can find codes for all different types of projects, from robots to autonomous vehicles to sensors to LEDs. Like all what I'm about to show you, you can all find online. It's all open source. So if you don't catch it, if you don't understand what I'm saying, you can always go back online and try it for yourself. So first, just a little syntax of coding with Arduino. They have their own IDE somewhat. It's a little window here, and each code is known as a sketch. So this is sketch December 13 because today's date. Yeah, really not that important. But but the main components actually that have to be in a sketch is a setup method and a loop method. What a setup method does is sets up your pins. So basically, you have digital and you have analog pins. Digital pins are basically pins that go high and low, like a light switch. You go off or you go on. And then you have analog pins that are variable by voltage or current. So for our purposes, we just need to do digital pins. So let's do the first one, which will be just turning on, let's say the red LED light. So the first thing you want to do is you want to initialize a variable that will hold the value of your pin. So let's say, for instance, we can call red pin is equal to pin, let's say, for instance, 13. And this is all done in C++. So if you're not familiar with C++, there's a lot of tutorials online you can go to. If you are familiar with C++ or C, you can follow along with this. So right here, we initialized our variable for our pin called red pin. Another method that Arduino has a bunch of built-in methods so that you can interface with the pins. And just a quick side note, a lot of people think that the Arduino is not really, it's really the big board, but the Arduino itself is actually this little chip that's on that big board. This chip right here is what's actually known as the Arduino. This whole board is called a breakout board. And what the breakout board does is all these pins on the Arduino chip are too close together. So you put the chip in the breakout board, and it separates the pins so that you can connect a lot more easily than if you just had the chip itself. Plus, it gives you other stuff that makes programming a lot better. Like you have resistors, you have transistors, you have capacitors, and you got some other funky little hardware stuff. I don't know what they are. Some of them only have a reset button, so it's pretty sweet. But enough rambling. Let's go back to the code. Okay, so you have your pin. So there's a method known called Pinmode. And what Pinmode does is you give it the pin, which is red pin, and you tell it what you want that pin to be. So pins can be either inputs or they can be outputs. Inputs meaning that you take in signal from somewhere. Output is you sending out a signal. So with ours being a digital pin, we want this to be a type output. All right. What this means is that we're not taking anything from the LED. We're just trying to send out signals to it. And to do that is very simple. There's a method called digital write. And what digital write does, it will digitally write either a 0 or a 1 based on what you put in. So let's say the red pin, for our pin, you want to digital write high. High means 1, low means 0. So there's a few things about, now you've basically, the sketch, the code is all written. That's it. That's all we need to write to turn the pin on. To make sure that the code is actually syntactically, if that's a word, if it's correct, there's a verify check mark. You can click verify. If it's done, if it's compiled, that means that everything works. Let's say, for instance, we don't have a semicolon. You press that, it tells you, yeah, you're missing sound. So it's pretty cool. It allows you to catch your mistakes even if you don't catch them yourself. So the code is good. The next thing you want to do before you can even upload to your device is you want to make sure that your device is actually plugged in. And what I mean by plugged in as in, if I can turn this back on. Majority of the Arduinos, they come with the USB cable. And with the USB cable, that's what you plug into your computer. And I'm trying to turn on my camera, but for some reason, there we go. Okay, so mine is plugged in with this little purple-looking cool, cable that goes to my USB port. My camera's on my laptop, so I can't show you exactly where it goes into. But yeah, so it's plugged in. When you plugged in, the Arduino gets powered. It's plugged in, so power comes either by the USB cable, or you can plug in a outlet plug charger type thingy, a 9-volt, I think, and you can also power it that way, which I'll show you later on. So now it's plugged in. The computer has it plugged in. I'm running a Mac, so I don't have to load drivers or anything, but with Windows, I think you have to do that. But all that can be done. There's a tutorial on Arduino.cc. That's the main website for Arduino. You can learn how to set up. It's pretty easy. So next thing we want to do is we want to select our board. I have the Arduino Uno. As you can see, there's many Arduinos out there, literally. So the one I'm using is Arduino Uno. The next thing you want to check is the port at which you are connected via. So there's various ways you can do this. You can do this either with Bluetooth. You can have a Bluetooth model with your Arduino and turn on the Bluetooth with your laptop and transfer code that way, or you can do via USB. I'm not sure what TTY and CU really means. They both work. I don't know what's the difference. So for now, we use TTY, which is it works. After that's done, everything's good. All you have to do now is press the go button, which is the upload button. So when you upload your code, it sends it to the Arduino, and what Arduino will do is execute your code. So what we did is to turn on an LED light. And I don't even know how to do this better. Alright, so it turns on our LED light. So as you can see, we have our red light. That's it. That's all we wanted to do, and that's what it did. Okay, now let's go a little bit more advanced, and let's make 2 LED lights blink. Not really blink, let's make sure that 2 of them can turn on at least. So because once you have them turned on, then the blinking comes into later. The blinking incorporates other stuff more like timing deals, which is it's not that complicated. But let's go back to our code and let's create another pin. Call this one the green pin. So a green pin will be, how did I write this? White one. The green pin will be in pin A. Okay, so what we want this pin to be, we want this pin to be of the type of a pin mode of an output. So green pin, the output, I can't, there we go. And all we have to do now is the same thing that we did with the red pin. And you can just copy it, paste it, and we can say green pin. That's to go high. Okay? Wow, beautifully uploading it, and hopefully, surely, we have two LEDs lighting up like eyeballs. And if I can get this camera to work. No, that's not the right one. It's supposed to be this one, I think. Yes. Sweet. So now, turn it this way. We have two LEDs. See, like two eyeballs, red and green. It's beautiful. All right. So what we're gonna do now is we're gonna make them blink, which is pretty cool. Making them blink is kind of fascinating to me. You know, my first time I learned this, that's what I did. It's pretty cool. Blinking incorporates basically turning it on and then turning it off. We can do that, and it will blink rapidly. To show you how fast it actually blinks, how fast signals are being sent to the LEDs. We're not going to put any stops or nothing to it. We're just going to we're going to turn them as soon as they turn on, turn them back off. All right, so we're going to do the red pin, go low, so that means we're going to send a 0, which means, you know, turn off. And then we're going to send another one for a green pin. And we're going to tell that one to go low. All right. And what that would do is just take on, off, on, off, on, off, on, off. But honestly, you see a difference? All right. I will show you what I'm looking at is that you don't really see the rate at which signals are being sent to these LEDs. You can't even see them blink because they're going by. The signals are sent so fast instantaneously that it's kind of very hard, you know, to actually see blink. So what we would have to do is we can slow it down. Basically, we can do a pause. So basically, what we're going to do is we're going to pause the Arduino from sending signals between high and low. This can be done with the delay method. Inputs for the delay method are in microseconds or milliseconds. So if I say 100 milliseconds, that's not really it's not a second, it's 1/10 of a second. So they'll be basically blinking pretty fast. And we can show you that. Oh dang, it doesn't blink whatsoever. All right, go back. Why are they not blinking? Red pin, green pin. Now let's try this. I'm having a little technical difficulty. It was working a couple minutes ago. What's going on? Why isn't this working? Green pin, red pin, both of them are on. But for some reason, they don't want to blink. That should work.
Do you have to put another delay after it turns low?
Let's try that. Let's put another delay here. But it doesn't even turn off. That's the question. Yeah. That's the problem. Okay, you figured it out. Oh yeah. Okay. As I said before, when we didn't have the delays, you really couldn't see them blink. So even if I put one delay in there, all it would do is going to go high, stay high. After 100 milliseconds, it will go low. But as soon as it goes low, it's going to go back high. So that's why it wasn't really blinking. So I had two in there. So you add two delays in there, it will go high, go low, stay low. So you actually see the transition between high and low. So yeah. So now these puppies are blinking, which is pretty cool. And we can do all sorts of fun stuff with this. You know, you can make them blink each a different set of time. So let's play around with it. We got time. So let's do some fun with this. So let's say we want to make the green pin low first instead of high. And then we're going to make it go high afterwards. And what that will do is just give us an alternate, you know, high-low. A high-low sequence. So what the high-low sequence looks like is like police lights blinking. Which pretty, everybody knows police lights. And there you go. So now we have two LEDs blinking each at the same time. Now on to the grand finale, the big boy, is the Sonar Sensor. So one thing you should know about the Sonar Sensor, this thing right here, is majority of them come with 3 pins. A voltage pin, a input/output pin, which is used for the ping and the echo, and then you have the ground. In basic circuitry, to have a complete circuit, you have to have a voltage and a ground, so it can complete. Because when power goes into the voltage connection, and then it goes throughout the circuitry, then it comes to ground, and that's like a cycle. It's the same thing with the LEDs. From one pin on the Arduino, which sends a signal, goes into one pin on the LEDs. The other side comes to ground, so it completes the circuit. If it doesn't go to ground, then the LED does not blink. If I put it back to ground, the LED blinks because I complete the circuit. With this Sonar Sensor, it has 4 pins. It has a voltage pin, and it has a ground pin, but it has 2 other pins that are each designated for their own purposes. So instead of sharing one pin, instead of sharing one pin for the trigger and the echo, you have one pin that triggers the echo. You have the other pin that listens in for the bounce back. So basically, what we'll be writing next is a code that will basically say, it's basically setting up the pins, then setting up the pin modes, and then just executing the echoing and the listening. It's a fairly almost physics in a way, somewhat, but it's very not that bad of a programming scheme. So instead of me talking, let's just get to it. Sweet. Okay, so that's our LED sketch. You know, looks pretty sweet. I want to save it though. That's pretty cool. So LED 2. Oh, that's a good thing about this program is you can write your own sketches and you can save it, and then you can open them back up from, you know, and then also you have various tutorials or sample codes that you can use. So you can, let's say for instance, this is basically what I just did is the blink without delay, which is very similar. So they have the same thing where, you know, they have a pin, then they have a state. You know, there's various things you can do with this, but just the basics of what I did was I did the pin mode, and then without this logic, I turn it to high and low, and then I digitally write. That's basically what I did. But you can add logic to whatever you want it to do based off of how you want it to, I guess, perform. And that's the thing with hardware. That's if you wanted to do something, it's at your hands. Computers are dumb without humans' interactions, so it's pretty cool. So what we'll be doing is writing a sketch now for the Sonar Sensor. The Sonar Sensor, as I said, it has 4 pins. So let's initialize those 4 pins. So first pin, the echo pin, we can say that pin will be, okay, let me see how I set up on my board first. Echo pin is there, you come here, it's this orange one. Orange one goes into 4. So echo pin goes to pin 4. Then the trigger pin is in pin 7. Oh, forgot my semicolon. And then the other pins, the voltage and the ground, we don't need to set in here because we can connect them directly from the Arduino. The cool thing about Arduinos are that, let me pull up this camera, you can see it. So the cool thing about Arduinos are that they have their own, I don't know if I can say, so there's certain pins designated for certain reasons. You have GND, which is the ground pin. You have 3 of those on this particular breakout board. You have a 5 volt pin, and you have a 3 volt pin, as well as a reset pin, but we're not going to use that today. What we'll be using is the 5 volt pin, because the sonar sensor requires 5 volts to turn it on, and the ground, so that we can ground the entire circuitry, just as we did with the LEDs. Let me struggle for this one. All right, so we have our trigger pin, we have our echo pin. What we're going to do is also bring back in the pins for our LEDs, because we want to incorporate those in our final design. So we can say, we just do the red pin, and I forgot what the red pin was, 13. And then we're going to do the green pin. And I think the green pin was 8, yeah. Sweet. So as I said, we have to first do a setup, our setup method. If you don't have the setup method or the loop method, or neither, you cannot upload to the Arduino. It will not allow you anyway, so you're required to have that. So our setup is that we need to set up all 4 pins to be what we want them to be. So pin mode for, let's say, the echo pin. The echo pin is basically the pin that we want to listen in for the echo. So this would be an input. So we can say echo pin input. The next pin we're going to do is the trigger pin, and you can guess what the trigger pin is. It's type output, because that's what we need to send a signal to the sonar sensor for it to trigger basically a ping. The other pins are the LED pins, so as we did before, they will all be outputs. And let's copy, you got typing on that. And they will all be outputs. And another thing that we want to do that I haven't talked about yet is something called a serial. Serial is a communication, I guess, a way of communicating between a device and the Arduino. It's just like Bluetooth or USB. Serial is a more low-level type of communication. So what we're going to do is we want to begin our serial at a certain baud rate, which is the rate at which signals are being sent. So there's a method called serial. We want to open up a serial connection, and we want it to begin with a rate of 9600. That's almost standard. Certain hardware that is implemented with Arduino use higher baud rates, but for the sonar sensor, 9600 is sufficient enough. So we did that, and also what we're going to do is that we're going to create some other variables, some just like maximum distance, just so we can use later. So we can say max distance. We can say min distance. I don't know why I just did that, but and I spelled distance with a capital I. Don't know why. Didn't that mean for that to rhyme? Yeah. And then we want to also the calculations. We have to do our own calculations, because it will come back at a certain. It's going to give us a speed, but for us to understand it, we have to calculate it. So we're going to need some variables. We're going to need a duration, which is how long it took for the echo to come back. We're also going to need a distance. And those 2 variables. So basically, that's all we need for now. So now we get to go into the fun part, which is the loop. This is where we're going to be doing our calculations, all the setting up and stuff, and it's pretty sweet. Okay, so the thing with the sonar sensor is that what it does is it sends out a ping, but if to negate basically some variables such as like noise, any type of objects or intrusions in front of the sensor. To be as accurate as possible, what we're going to do is we're going to basically toggle the pin. So we're going to make the pin go low first, and then we're going to toggle it high, and then we're going to toggle it back low. So we're going to turn it, we're going to make sure it's off, then we're going to hit it high, then we're going to turn it back off as quick as we can. So it's another function. It's called delay microseconds. It's a lot because the method delay itself is milliseconds. So we're gonna need another method that goes by microseconds, so we can turn it on and off as quick as possible. So let's write this. So the first thing you want to do is make sure it's off. So trigger, pin, and low. Make sure that puppy's off. Then we're gonna call this thing called the delay microseconds, and we're gonna do like 2 microseconds. I don't know. You can try it with delay of like what, 0.002 or 0.02. That might be 2 microseconds in milliseconds. I'm not sure, but you can do that. Try that. But the method delay microseconds is built. It was created for this purpose. So after we turn it off, shortly after, then what we want to do is turn it back on. So what this will do is that it will send a signal to the trigger pin, and the trigger pin will initiate, basically send out a ping. And we're going to make it do it for 2 microseconds. And then afterwards, we're going to turn it off. I don't think you have to do this right here. No, we don't have to do the microsecond, because when you turn it on, make sure it's low, then you turn it on, turn off for certain minutes, certain amount of microseconds, turn it back off. Then what we'll do is we will trigger the echo pin. And what the echo pin will do is listen in for all the feedback. So we want to set our duration variable, because this is how long it takes. So there's another one called pulse in, which is another built-in, but it's built-in, as I say, Arduino is open source, so people have created methods for certain hardware. Sonar sensors are very popular, they're very widely used, so there's certain methods that have been created that will basically do what we need to do for any type of sonar sensors. So delay microseconds is one, and another one is called pulse in. Pulse in does the same thing as what digital write does, I believe, because what it will do, it will basically trigger something. It will tell the pin to do something. So in this one, we want our echo pin to go high. That means we want it to turn on and start listening. So yeah, that's all we need to do. So right here, all we did was we sent out a ping and we are listening back. That's all we're doing. You can't really see anything right now. So what we'll do is there's a method for serial called println. So for people who've used, I think Java has this. Println. System now, yeah. So I'm not sure, but you can. There's a method called println, and what that will do, it will print to a monitor on our screen, which I'll show you afterwards. And what we can do is we can print out the distance, the duration. So basically, I'm just showing you basically raw of what's coming in. All right, sweet. So let's do this. Okay, sweet. 0 can be used as a function. What? 0. I don't see 0. But let's do that. That should be cool. All right, beautiful. All right, let's upload it. All right. I don't know if you can hear that, but it basically just fired up. Basically, I don't know if you can hear it.
I can hear it.
All right, sweet. But it just basically fired up. So what I'll do is I'll turn on the serial monitor. This is the monitor that's basically telling us what we're getting back. So you can't really hear. It's like a humming noise, but that's just basically the ping that's going out. So right here, all you're seeing is all these raw numbers coming back. I don't know how much, I don't know what measurement this is in, but this is what's coming back. So there's nothing in front of it right now, but if I put my hand in front, you see how smaller and smaller the number gets. And then, let me use my phone. If I move my phone in the front, you see how small the number gets. if I take it away, see how big it gets. All right. So the farther away you get, the bigger the numbers get. So this is actually working, but we don't know in what measurement. We can't tell how far things are. So what we'll do is we'll basically convert this duration into a distance. I'm not 100% sure what this thing is in, but I Googled it, the code for this thing, and the distance is calculated in centimeters. So what we'll do is that we'll calculate it in centimeters, and then we can calculate it in feet for the for the people in the United States who use their metric system. So duration divided by 58.2, and this will give you the measurements in centimeters. All right, so we can. Another thing about print line is pretty sweet. You can write your own stuff in there. So I can say serial dot print ln. Matter of fact, let's do this. Take out ln. Print is also a function method. The difference between print and print ln is that print will just print everything out in one line continuously. Print line is that every time it prints something out, it goes to the next line. So we wanted to print duration and then put centimeters at the end of it. Yeah, and then the ln will make the next measurement go down. Sweet. So let's compile this and let's run it. Turn on the serial reminder. So now it's pointing at a window. It looks like it's accurate, 1,000 centimeters. I don't know if that's accurate.
Yeah, it's about, yeah.
About right?
Yeah.
All right, sweet. I put my phone in front of it. It's at 100 centimeters, which, yeah, it's about accurate. Sweet. So now let's convert this to feet. You know how to convert centimeters to feet?
No.
How about meters to feet? Damn it. All right, let me just do some Googling. 1 second. I'm terrible. I should have known this, but I don't like math that much. So 1 meter is how much ever feet that is. So let's do this. Let's do centimeters, so we can do this accurately. So 1 centimeter is that much feet. All right. So wait, that makes no sense. Well, that makes no sense. How much centimeters in 1 feet? There we go. Wait, that makes no sense. So 30.48 centimeters gives you 1 feet. Sorry, guys. All right, so let's wrap this thing right here, and then we're going to divide by whatever measurement we got from Google. And we're going to take you from centimeters to feet. And turn you on, turn on serial reminder. Oh, wait, not right. So now, that does not look right. That definitely does not look right. It's duration by that divided by 30.5. What is this thing? Oh, I was still doing duration. Excuse, I'm sorry. This is supposed to be distance. Then the serial reminder. Aha. Well, that's saying 0 feet. I made my calculations incorrect. Maybe that's 9 centimeters then. Maybe that's not in centimeters. It should be. With that measurement scale, think. All right. I guess it was in millimeters. Is this a foot?
No.
Okay. That's definitely not 4 feet. Yeah. What 4 would this be? A 4 meter? I don't know. But there you go. You can see it works. Calculating now how the distance is. You can Google it. I'm very sorry. I should have did this before. But yeah. So basically, we have our sonar sensor working. So based on not these calculations, let's use a more precise, somewhat calculations where we can have different ranges of numbers. Because all is just for show. There's nothing to be We don't want to be very, very, very accurate whatsoever. So we have different ranges based on different where we are in certain spots in this room. So I think this was in front of it. Guess not. Yeah. All right. So this max that this sensor can sense up to is 46 feet, or I don't think about that feet, but 46. So if I bring something in front of it and go closer and closer and closer and closer and closer, the numbers change. So let's incorporate the LEDs with this. Let's say, for instance, let's set our max distance to be, it says 46 right there. Let's say our max distance to be 40, and our minimum distance of 0. Not distance 0, but yeah, minimum distance of 0, a max distance of 40. So what we want to do is we want to create a conditional that is going to say if the distance is greater than the max, turn on this LED. If it's less than the min, turn on the same LED. But if it's between it, then we're going to make sure that the LEDs, basically turn on occasionally. But so basically, if we're within a certain range, we want our green LED to turn on. If we're outside of the range, we're going to make our red LED turn on, which is not that bad. So I'm just add just a little delay in here, 50 millisecond delay, just so everything can flow a little smoother. And we can stop collecting so many data points because we're not really being we don't want to be that accurate. Where's the loop? Where did I put that delay? It shouldn't be in setup, sorry. It should be take you out. Okay, so after the duration, what we're going to do is we're going to make if statement, if conditional, that says if the distance is greater than or equal to, matter of fact, just greater than our max distance, is what's called max distance, or if the distance is less than our minimum distance. All right, so if it's greater than the max distance or it's less than the minimum distance, what we're going to do is we're going to turn on the red pin. So that means, yeah, we're in the red zone. So you're going to do a digital write, so we can write to our pins, and we're going to write to the red pin until it's turned on to go on high, and all caps. The good thing about this IDE, or this programming tool for Arduino, is when you wrote something right when it changes colors. So methods are in this color. Looks like, I'm very colorblind, so it looks like a green. It's not green, but I don't know what color this is, but it has a certain color. The pin, like the pin types are a color, and the outputs are another color. And there's various color schemes for different things when using Arduino. But for our purposes, let's just continue. So if we're outside of our range, we're going to make sure our red pin turns on. If we're inside of our range, so if we're not outside of our range, we're going to turn the green pin on. All right, sweet. All right, so let's show you where is this hanging out? There we go. So this is what is happening right now. So right now, the red pin, and well, what's going on? Both of them are on. That makes no sense. Okay, so the red pin is on because right now I need to change something in here at a print line because it's printing everything in one straight continuous line. All right, so the red one's on because right now we're going at 152. That's far as hell. And if we come in 152, we're less than 40 and we're greater than 0, the green pin turns on, but the red pin stays on. If you remember, we did not set any of the pins low whatsoever. So if we go above 40, the green pin will stay on. And if we go below, I don't think we can go below 0. No. Nah. If we go below 0, which is at over 600. But basically, both pins on. We didn't turn any of them off. So, as I said, hardware is not that smart. It's smart when humans do something to it. So let's tell the pins to go low when we're not in the certain condition that we need to be in. So for outside of our range, we're going to make sure that our green pin is off and our red pin is on. And for the other case, we're going to make sure that our red pin is off and our green pin is on. Right, and that will this basically shows a more smoother transition versus us having both of them on, because we need to turn them off when we're either within our range or we're outside of our range. And let's upload it. And you turn the serial monitor on so we can see. So right now that's the distance, that's the variable rate, that's the, I guess, the distance we're getting back. And this is what's going on. Right now our red pin, our green pin is on now. For some reason I think distance are changing because I'm moving it. Alright, right there. So that will, there's some very weird things going on. Get bag, pins. And there we go. So the red pin right now is on because we're at 157, 156-ish. And if I move it, okay, we're still above 40 and the red pin stays on. Once we go below 40, the green pin turns on and the red pin turns off. If I go above it, it goes back and forth. So, you know, it's me doing this. I don't know if you can see me doing it, but I'm yeah, I can't do both. But yeah, so this is a cool application. So let's say, for instance, if you want to do an autonomous robot and you want to do collision detection, this is a good way of doing it, where you have a sonar sensor and you can calibrate your sonar sensor in any way, shape, or form you want to calibrate it in, so that you can calculate distance. So let's say, for instance, if your robot gets too close, it turns, once it gets too close, the state switches. And that signal that we're getting, we just have a check based off of the variable we're getting from the sonar sensor. So you can have that and tell the robot stop or turn or slow down, and then once the distance changes, it does something else. So it's very state-based, which is pretty cool. Back in college, I did the same thing. I had an autonomous robot do collision detection, and it basically ran through the hallways, made left turns, right turns on its own without hitting the walls. So this is a pretty cool thing. Arduinos are pretty cool, and it can build very powerful implementations on just basic knowledge of coding. For more problems, and you can do a lot more with Arduinos. There's a lot of tutorials out there. There's a lot of hardware that you can buy. They're not expensive, but you have to purchase them. And there's a lot of stuff that you can do with it. Like you can create, you can do robots by, you can change speeds of motors, like this motor right here. You can get a motor shield for the Arduino, so it will basically fluctuate voltages between various motors that you have. You can get a push button. You can get a rotary pulse modulator. Like there's various applications that you can use Arduinos for. I don't know what this is, but this is another one. There's various chips out there. There's various there's accelerometers. You can use accelerometers with it. You can use 8-figure displays with them. And I had the kit. The kit costs $30 on Amazon. You can go out and get it. It's fun to be a hobbyist because you can build all sorts of stuff. And it's pretty cool. So I think that's all I have for today. And I'm ending quite early, 30 minutes early before schedule, which is not that bad. So if there's any questions, you can send Alyssa your questions, or you can type them in the box next door. But thank you for joining, and hope y'all learned a lot. All right, thank you.
Thanks, O'Dwayne.
Thank you.